Hello everyone, welcome back. Very good morning. Today we are going to cover another important chapter, how JavaScript handles data. So in this chapter, what we are going to cover, let's have a glimpse of it. Data types, the kinds of data, primitive, non-primitive, then how JavaScript actually stores data in memory, how it stores primitive data, how it stores non-primitive data, what is memory, how we have to consider certain important things to know about the memory consumption, to know about means before actually reading real data structures and algorithms, before implementing array, stack, the beginner's problem, mid-level problem. Before talking about those things, we should know the basics, right? If your foundation is strong, if your basics is strong, then definitely you are going to be successful as a software engineer. And you will never be confused why DSA is important. Okay. So all these things we are going to discuss in this chapter. Without any further delay, let's get started. Data types. The kind of data. So every piece of information in JavaScript belongs to a specific data type. Let's talk about real world scenario. Suppose I am talking about a fruit. Okay. So whenever I say fruit, if you are listening to this, then you have an idea which thing I am talking about and what I can do with that. Right? But if I say vegetables, okay. So these are all vegetables, right? If I talk about vegetables, then you definitely know what I can do with that. Okay. So if we know the type of item, whether it is fruit or vegetable, then you can guess what I can do with that. And you know the limitations and the actual use case of that item. Okay, everything about that item once you know the type of item. Suppose I say furniture. Okay, now you know that what it is. Okay, these are the type of items. Similarly, in computer programming, you have to know what this chunk of thing or this item means, what is the category of this item. Okay, you have to know that, then only you can deal with it properly. Okay, think of data type as categories that tell the computer what kind of value a piece of data is and what operations can be performed on it. Okay, basically there are two types of data if we divide them based on their memory consumption. Number one, primitive data type, and number two, non-primitive data type. Primitive data type means those are simple, okay, like string, number, boolean, undefined, null, big int, and symbol. So simple means I am not talking about your understanding level, which is simple, which is complex. Okay, I am talking about how it stores in memory based on that, the simple and complex thing. Okay, so more about these things we will discuss one by one. Don't worry for that now. Suppose string stores hello, DSA, name of a person, name of an institute. Okay, textual data it encloses with in double quotes. Then comes numbers, numeric values including integer, floating point, those type of things. Then comes our boolean, true, false, either true or false. And where we use this type of data while writing logical things. For an example, a student. A student will go to school if it is not a holiday. Okay. So if we are going to write a program for a student, whether today he will go to a school or not, then our program will be something like this. If not holiday, go to school. Right? Similarly, for an employee, if not holiday, then go to office. So these type of things, if not holiday, now what will be the result of this? Either yes or no. If I ask you whether today is holiday or not, what you will say? No or yes, right? If I ask you, is it Monday today? No. Is it Tuesday today? Yes. Okay. So there are different questions whose answer can be only yes or no. Those answers we can store in a Boolean value. Okay, true or false. Now, undefined, null, these things we will discuss more elaborately with proper examples later on. What is the actual use case? But for now, just remember that these are also values that you can store. So all these type of data types are called primitive data types. Primitive values are immutable, means cannot be changed, and represent a single simple value. So here you may get confused. Cannot be changed. What does it mean? Immutable, mutable, those things. So what does it mean that it cannot be changed? I think we have written somewhere here. Okay, let's go through the content. Okay, so we will come to this point later. Before that, we have to understand how this primitive data stores in memory. And what is memory? If you have a phone, okay, you may not have seen computer earlier, but all of you have seen phones, right? We are talking about storage. Let us say, okay, any mobile phone, suppose 4 GB RAM mobile. If we look at any phone, it has two types of memory: 3 GB RAM and this 64 GB. There are two types of memory everywhere, right? Similarly, if we look at a computer, let us search only in images. Yes. Okay. If you open the box of a computer, it looks something like this. Within this box, we have this RAM and this physical hard disk where we store data. All these things are available. But yeah, again, the question arises. Right? What is this RAM and what is this hard disk? When we are processing any information, those need to be stored somewhere, right? Now, see, I opened this operating system. So definitely it loaded somewhere. That's why we are able to see it. If I am opening this browser, then it loaded somewhere. That's why I am able to see it, right? Just give me 1 second. Okay. So let's see another picture of CPU. Here we can see a RAM. Okay. It looks something like this and installed in your cabinet of a computer. Okay. Every computer has a large cabinet and a monitor. So monitor is to display the input and output, those type of things. So you can see whatever you are giving input to the computer and what you are getting from the computer, right? Similarly, we have a hard disk which stores things permanently when you switch off the computer. Now we are talking about this RAM, random access memory, which stores your data and information while you are working on this, while your computer is switched on. We are talking about that thing. Okay. So now you got a clear idea about memory, right? So whenever we are writing something or we are running a program, it stores those data and whatever required in memory. Now, when it comes to primitive data, it stores in stack memory. Okay, there are two types of memory. If we organize it based on its uses, stack and heap. So this primary data, these are stored in our stack memory. Okay, and the dynamic data, what we are going to discuss after this, those are stored in heap memory. Now, what is the difference? What is the difference between stack memory and heap memory and how it matters? If you remember the previous chapter, what is DSA? At that time, we discussed about an example of a pile of plates, right? Where you put new plates one on top of another after washing. If you have not seen that chapter, then please go and first see that chapter, then come back. Okay. I will suggest that don't miss any chapter. At least these introduction chapters. Then when we directly go to the data structures, that array, linked list, then you can miss something. That's not an issue. If you want to start from array, then you can. But if you are going chapter wise, then it would be better. Okay. Okay. Not an issue. So let's. Yes, this one. Okay. So let's clarify you again. This stack memory. Here it stores one on top of another. So the last item that you kept here can be taken out first. Okay, last in, first out. Think an example of a pile of plates, as I told you. Okay. Let me show you that image again. 1 second. You will get a clear idea. Hmm, yeah, got it. So yes, this one. Okay. So here, When we wash some plate and keep on a table, we keep one on top of another. So the last plate that we kept in can be taken out fast, right? We cannot pull something from the middle. It is not a proper way. Generally, we are not doing that, right? Now come to our main topic again. So we are discussing about memory, right? So stack memory and heap memory. So stack memory, it stores those primitive values, the actual data. It also stores the references for non-primitive data, for complex data. Okay. So first let's discuss about primitive data. JavaScript online compiler. You can use any based on your choice, not an issue. Okay. Suppose I am writing let x equal 5. What I did, I created a variable x where I stored data 5. Okay, the value 5. 5, its type is numeric, right? So if I write console.log type of x, then I can say here number. And we already know that this number is of primitive data type. Okay. Now imagine how it will be stored in memory. So this x will directly store in our stack memory. Okay. Here, okay, these are examples of objects, okay, not primitive data types. Okay, so understand that here from here that when we are storing a primitive data type, it is storing directly in stack. Now, how it matters? There is a type of data which we call non-primitive, that is object. Non-primitive data type. Kinds of data, primitive data type. Yeah. So the most critical concept to grasp about JavaScript is data is how these two categories, primitive, non-primitive, are stored and accessed in memory. If you click this link, it will open the memory chapter where you can learn more about memory. Okay. Now, except this, all other data types are non-primitive data types. So suppose I am saying user name Ramesh and age 25. Okay. Now let's see its data type. So console log type of user. It is an object, and object is not there in this list. Means object is of a non-primitive data type. Okay. Now if I say x equal 10, or let us say I say x equal y. Y is not defined, so y equal x. We can say like this. Okay. Let y equal x. Console.log type of y. So y is also a number, right? Now let us say new user equal user. Type of new user, it is also an object, right? So what we did, we created x assigned its 5. Then we assign x to y. So now y also should be 5, right? Okay, y is also 5. And if we console log new user has the same things like name Ramesh and age 25. Okay, but why we need to know how it is stored in memory? Here it comes. Suppose after this we say x equal 10. Okay, now what will be the value of x? The value of x is 10, the value of y is still 5. Okay, now same thing we will do here. User dot name equal Suresh. Okay, now what happened? Mark the difference. X equal 5, okay, then y equal x, then x equal 10. And when we console log x and y, we saw that both the values are different, not same. But here we created a user variable. Okay, if you are not able to understand in a go, then you can repeat watching this video till you understand this, because it is very important to understand these concepts before going further. We created a variable user and assigned an object to it, okay, which has a name key and age key, right? We will discuss more about objects and its use. Don't worry that for now. For now, you can see that we created something within curly braces which has string as well number, both type of data. And if we see its type, then it is object. That's it. Okay. Now, new user equal user. So that user we assign to another user and change the user's name, not the new user's name. But when we console log new user, it gives us Suresh. And when we console log user, it gives us Suresh as well. Okay. So where is Ramesh? Now another peculiar thing I will. Yeah. Suppose I did new user dot age equal 35. Okay. So you can see both user and new user has name Suresh and age 35. So what you understood from here? If we are assigning like this and changing any of the keys, maybe from the old data or maybe from the new data, then it will reflect in both of them. And why this happened? This happened because it stores in a different way in memory. So name age, we have two things in that object, right? And age, it is an object, not a primitive data type. So it is not directly stored in stack memory. It's stored in heap memory. And the address of that heap memory is stored in stack. Okay, try to understand. We stored the complete data in heap memory and that address we stored in stack memory. When we do that, we do this type of thing when we have non-primitive data. Okay, and who do it? JavaScript, operating system, those guys are responsible for that. We don't have to worry. Okay, we declare a non-primitive data type and it automatically stores there. And why it do so? Because heap memory is huge. We can store anything there, but stack memory is very limited. As I said, you can read more about this in this memory chapter. Okay. So as stack memory is very limited, it stores the very important and sensitive information in stack only. Okay, not sensitive but important information, and operating system and the language they decide. Okay, as in this case, non-primitive data are automatically stored in heap. Okay, so how to handle these type of things? How we can change only new user of which will not affect user? Those things we will discuss later. It is not part of this chapter. Okay, we can do that. That is achievable. We can do that. But in this chapter, we are trying to understand how JavaScript handles data. That's it. Okay. In our object chapter, we will discuss more about how to store different values in a copy of a variable. Okay, so I think you understood the concept clearly. Let me revise it again. When we create a primitive data type, it stores in stack memory directly. Okay, so suppose 5, we stored 5. Suppose 7, it stored 7 directly. Suppose 8, it stored 8. So whenever you change the value, you change value directly at the memory. That's why it reflects here. Now, when we said y equal x, means we created a new memory portion in stack and stored 5 there, the same value. So now we have two distinct places, x and y. Okay, and 5 stored in both the places. Then we changed it from x only. So now x is 10 and y is 5. Okay, clear? That's why when we console log x and y, we see 5 and 10 because two distinct places and two distinct data. Got it? But when it comes to an object, we stored it in heap memory and the reference to that we stored in user and another reference we stored in new user. Okay, so the original data, the actual data is stored in heap memory. Its address only stored in stack with the name user, and the same address is stored with another name new user. So when you are saying that I want to change the actual data of new user is something new, then it changes here. Similarly, when you are saying that I want to change actual data of user, then it changes here at the same place. Okay, because both user and new user has stored the reference of that one. They are not storing the actual data. Now you got the idea? So if you think logically, how can we do something so that changing new user will not affect user? Okay, we can do that when we create a copy of this and store at another place in the heap, and that reference we will store in new user. Okay, this is the concept. How we achieve that we will discuss later in object chapter. Okay, clear? So to summarize, when we store a primitive data type, everything stores in stack memory. But when we create non-primitive data type, that's stored in heap memory and only its reference is stored in stack. When we assign that to something else, we are just assigning that reference, not the actual data. Okay, so when we say new user equal user, means we are whatever stored in the user, we are reassigning to new user. And we know that in user we stored only reference, not the actual value. Okay, so that reference, whatever stored in user, we assign to new user again. Now let's look at this example. This is the object which is in heap memory. Okay, we we stored its reference, the memory location address, okay, a hexadecimal value that we stored in our user, okay. In this example, it is object1, obj1. And then when we are saying new user equal to user or object2 equal to object1, the same address we are copying here, okay, not the actual object. So now both object1 and object2 is referencing to the same thing. Okay, this image is generated by AI. That's why I tried 2 to 3 times. Still, it is not able to do, and I don't want to consume more time on this. So I pasted this image. But these two lines, one is for object1 and one is for object2. Now, in our first picture, only object1 was storing the reference to the object, but in second, both object1 and object2 are storing the same memory address or same reference. Okay. I think it may make sense now, but still, if you have any confusion, then you can ask me in comments. Okay. So here everything is discussed in detail. What is stack memory, what is heap memory, and the mutability that we are discussing. Why primitive data is immutable? As we see in this example, x and y. Okay, we are reassigning something to x. Okay, but we are not changing its value. So reassigning means when you are writing some new value. Now, if you compare these two, object and this one, in case of object, we are changing value, right? So if you change something, then it reflects in both the cases. That's why it is called mutable. Okay. Mm. Let's see if we left anything. Yeah, whatever I explained, it is written here clearly. First in, first out stack, heap mutability. Yes, here we have written in detail. As mentioned, primitive types are immutable, meaning once a primitive value is created, it cannot be changed. Wait, but we can do this. Let x equal 5. So again, we can say x equal 6. Okay. So we are reassigning the value. This is not changing the value. Okay. A new value 6 is created in memory, and the variable x is updated to hold a reference to this new value. Okay, in stack, another portion is created where 6 is stored and x is assigned to it. Okay, so the original value, the 5, is it already there, but now x is not linked to that value, so we are not able to see. If we ask console log x, then it is showing us the new value. Okay, but in case of non-primitive, the objects, okay, these are mutable, means we could change the internal property of the object, because in stack we are storing only the reference, the address, the memory location, okay, not the actual value. So when you are changing the name, you are changing it from the heap memory. Okay, that's why we say that it is mutable. Generally, new students gets confused in this way, as they are able to change the value. So that's why they feel that yes, it is mutable. No, we are not changing the value. That's why it is important to understand how it stores in memory. Okay, based on that, we are saying mutable or immutable. Yeah, without reassigning the variable, the object's data on the heap was modified directly. Impact on DSA: operations on primitive variables always create new values. Okay, but operations on reference variables can modify the existing data structure in place, means in the heap, which is why we must be careful when passing them around or copying them. In DSA, this distinct is vital for understanding memory and side effects. Okay, by understanding the primitive versus reference split and the stack versus heap memory model, you can now have the foundational knowledge to approach data structures and algorithms with a much clearer view of how JavaScript actually manages the data we manipulate. Okay, excited for next chapter?